Okay, to start our unit on evolution, we need to talk about fossils specifically, fossils being traces of organisms that have been dead for a long time. They might include imprints of bones or imprints of things like leaves. What we need to know is, what have fossils told us about the history of life on Earth? And that's what we're going to take a look at. Okay, to understand where we get how old things are in the Earth's history, we need to understand a common sense law called the law of superposition. The law of superposition simply states that new layers of sediment are deposited on top of older layers. So the bottom layers should hold the oldest fossils. So in this cliff, you see stripes, they're called strata. And the oldest fossils would be on the lower stripes, and the newer fossils would be at the top of the stripes, the upper stripes. We call this relative dating, and we're not talking about dating your cousin or your brother or sister. We're talking about in relation to one another. The ones on the top are younger than the ones on the bottom. But it gets a lot more complicated than that, and that's what we're going to talk about next. Okay, unfortunately, it's not that easy. The law of superposition only works when there's no erosion, which of course there's always erosion, especially when you're talking over huge time periods like millions and hundreds of millions of years. So first of all, let's just talk about how this happens. Sediment is deposited. That's the law of superposition. But then eventually, and look at slide A there, eventually, now for slide B, the top layers begin to erode over time because of wind and rain. Then more sediment gets deposited on top of those eroded layers. And now look at section C and look how those lines are starting to get blurred and confused. And then the whole process happens again. The top layers erode again, more are deposited. And so what might seem like a really easy concept, the oldest fossils are on the bottom, the youngest fossils are on top, is in fact much more complicated because of this process of erosion and resedimentation. So trying to get which organisms are older or younger is difficult, and we don't even have years. We just have a sense of which is older and younger, and even that we're not very certain on. So then scientists came up with something new. Okay, relative dating can be misleading because of erosion and resedimentation, but it's also problematic because it doesn't give us any dates. We don't know if the lower levels of sediment are 100 years older than the upper levels, or whether they're 100 million years older than the upper levels. So scientists started coming up with a new way to calculate dates, and it's called radioisotope dating. And this gives us approximate dates when things formed. This is how they do it. They measure the amount of a specific isotope in a substance. They're able to calculate levels of this isotope throughout history, and then they're able to use that to calculate how long ago something was living. Isotopes decay with time. So older objects have smaller amounts of the isotope than younger objects. So because they're able to calculate how much a given organism should have, when they actually look at the fossil itself, it'll be missing some because some of it has decayed. They can tell how long ago that organism lived based on how much it has decayed. So the way that they do that is there's something called a half-life. Half-life is the amount of time it takes for half of the isotopes that were originally present to decay. So for example, let's say a woolly mammoth was alive, we'll say 10,000 years ago. It would, at the time that it was alive, you would expect it to have 100% of its, and I'll use this data table, 100% of its carbon-14 molecules. After it's been dead for 5,730 years, you would expect it to only have half its predicted amount. So that's what the half-life is. After 5,730 years, 50% of that carbon-14 has gone away. Now, after another 5,730 years, this is the part that's confusing, it doesn't run out of carbon-14. You take half of that amount from the last time. So half of 50% is 25%. So after roughly 10, 11,000 years, that woolly mammoth would be missing about 75% of its carbon-14, about 25% would be remaining. And they can use that information to calculate backwards how long ago that woolly mammoth survived. Okay, one of the things that scientists are looking for when they look at the fossil record is evidence of what are called transitional species. Transitional species are animals that appear to be intermediates between the hypothesized ancestors and their later descendant species. So if you take a look at this picture, for example, the whale, we know that the whale is a mammal. And so they've hypothesized that the whale's ancestor, the original ancestor, was a wolf-like animal that lived on land. So then the question is, can we find fossils in between that wolf-like animal and today's modern whale that show it changing over time, show it transitioning over time from one animal into the next? And the answer is that they actually have found quite a few transitional species between the wolf and the whale. As an FYI, not as many transitional fossils have been found as they originally expected. We're going to talk about that a little bit later, why scientists haven't found the transitional species that Darwin himself had actually predicted. And finally, an interesting part of the fossil record that the fossils have indicated is that throughout history, there have been these mass extinctions where large numbers of plants and animals suddenly disappear. There's one mass extinction that appears to be going on today. They refer to it as the sixth mass extinction. And that's due to human interference, burning down the rainforests, that kind of thing. But in the past, some of these species, some of these mass extinctions may have been due to massive impacts of asteroids or massive volcanoes. And any of those that disrupt the environment dramatically can kill off many, many species, and then life has to sort of start over again. The mass extinction happening now again is due to human interference. And that's it.